Right, now we come to probably the most complex concept. And this is where we start talking very seriously about relational databases. Relational databases are made up of two files related together using a referential constraint. Now, a referential constraint joins a parent file to what IBM calls a foreign key file. I have to use that word because that's the one they use in all their documentation. The important thing to remember here is that the constraint is defined in the foreign key file. It's not defined in the parent. So all referential constraints are defined in the foreign key file and point upwards to the parent. The parent file, because of that, requires either a primary or a unique key in order to define that relationship. The foreign key file requires fields matching the parent primary or unique key exactly. Now this is got to be carefully thought about. In my foreign key file, i.e. my dependent file, my child file, I have to have fields that match my unique key in my parent, either primary or unique. They have to match. They do not have to form part of the foreign key file's key, i.e. they do not have to form part of the primary key on this file. They can be anywhere. They can be attributes that are not part of the foreign key file's key. But they must match the parent's primary or unique key exactly in two ways: attribute and sequence. The actual data name of the fields is irrelevant. So when you define the constraint in the foreign key file, you're pointing it at the parent file, and the fields you choose out of your foreign key must match exactly the primary or unique key. Now, I will attempt, if I can. I'm checking it first on the other screen so that I can find one. Ah, there we are. Yep. I can show you one defined as it appears, as it presents itself inside AO. We have a master file. Don't worry about the color. This is my test environment, and I busted something, which I'm sure you're all infinitely familiar with. Should be green, but it isn't. But the information here is valid. I have a customer master file in my little database, which we will see a lot more of later on. And obviously, its primary key is customer. In fact, I'll show it to you. That's the record in the customer master file. It has a primary key of customer number, but it has also got the rep code. The rep code is not part of the key. It's a field, but that rep code defines the rep that owns that customer. Logical type of third normal form file. No problem. The constraint is defined here, and it is That's its name. R0 is a referential constraint number 0. I've never ever had to go beyond 9, but if you want to, you can go A to Z. It's a referential constraint, customer master file. It's defined in and on the customer master file. Its foreign key is rep code. Its parent key and its parent file are the sales rep master file and the rep code on the sales rep master file. So what we're looking at here is a referential constraint defined on the customer master file and related to the rep master file in a relationship. We can have a look at that. I will I'm actually going off the reservation here. FD, looking at the constraint there, is the primary key constraint. Right, here we are. I found it. Oh, I was lucky. I'm so happy. Right, here is the constraint. This is a customer master file. And its primary key constraint has got that name, its type of primary, it's got a key customer number, one number of fields in the key, key length is 4. That's the primary key definition. Here is the referential constraint. It's a constraint name, cusmaster R0, and you can see it's within the definition of the customer master file. Take note of that. It's the foreign key file in this case. It's of type referential constraint. Check pending. I will go into some detail just now. The status is established and enabled, and then it refers to which parent. The parent is the rep master file. The parent key field is rep code. The foreign key field is rep code, and there immediately you can see the benefit of having consistent naming conventions for the same data element, because they match up and they're easy to understand. So, well, I'll bring this back just now. What we have created here is we've created a relationship between this file and that file. And because the parent, which is the rep master file, has got rep code as a unique relationship, it's a unique key. The relationship here is a 1-to-1. It's a 1-to-1 relationship in this particular case. Because you are defining it from the bottom up, and because the customer number has a single rep code, it can only point to one rep code in the master file. Therefore, it's a 1-to-1 relationship. Let's have a look at some of the other information around the constraint. I'm just checking to see. Yeah. There are a couple of other things that constraints, once established, that constraints can do for you. There are two rules that are driven by constraints or managed by constraints. One is the delete rule. And I'm going to go back. In fact, let me go back and actually bring up the add PF. So the same command, add PF CST. This time I'm going to use and it's a ref CST. The constraint key is rep code. That is the field that is being used inside this foreign key file as the constraint key. The name I'm generating is CUSMST0, because that tells me that it's R0 for that file, because it's defined on that file. The parent file is webmaster file. And I can get away with not filling this in because the default says take the primary key from the parent file, or take any of the keys that match from the parent file. So I don't have to fill it in. These delete rules, the delete rule is very intriguing. And I will tell you right now that you as developers, when you understand what this is, will be very interested. It has a number of different values. No action and restrict. Now, I'm going to let you read those one day all by yourself, but they look almost identical. But they're not. So I choose either no action, which means that the delete rule is effectively not in effect. The other one that I use is a rule called cascade. And this rule says to the database management system that deleting a record in a parent file causes matching records in the dependent file to be deleted at the same time when data for a null parent key matches data for a foreign key. So when you delete from the parent, you will delete all records from the foreign key files that match the parent record that you are deleting. It's very, very useful for things like invoice header, invoice details. Means if you want to get rid of an invoice out of your database, you delete the header and the details are gone as well. It's not such a good idea when you have this particular constraint we're looking at now, which is between the rep code and the customer. Particularly if the customer is also cascaded into the invoices and the invoices are cascaded into something else. That means you can wipe your database out with a single delete. Not a good idea. So you have to use it with caution, but it does have an incredible amount of power in keeping orphan records out of the database in a lot of circumstances. So it's well worthwhile examining this every time you create a referential constraint between two files. Carefully examine whether the cascade delete is applicable or not. Remembering that I can have 20 foreign key files all linked to the same parent. I'm going to say that again. I can have 20 foreign key files linked to the same parent. If some of those 20 have cascade and others don't, when you delete the parent record, you're going to smash up your database because you're going to delete those that have cascades and you are going to not delete those that don't have cascades. So relationships built using the referential constraint are not tinker toys, and they must be considered very carefully. We draw relationship diagrams with great abandon in a lot of cases. They can be very powerful, very useful. They can cut down heaps of lines of code. They can manage the database very nicely. They can make sure that you cannot put a record into a foreign key file if there isn't a record in the parent file. I can make sure you can't delete a parent record if there are foreign key records there as well. These are all parts and parcel of the validation of the database that you can remove from your code because you don't need it anymore because the database is managing these types of relationships. But like everything else, a quick definition can give you an immense amount of power. But it can also, if you don't think about it properly, it can create chaos, which is why test environments must mirror production environments in every respect so that you can be sure that you are testing properly. I don't use set nulls. It's to do with null parent keys. I don't use nulls a lot in RPG database or in DB2 databases. Set defaults. Updates matching records in the dependent file when the data of one non-null parent key matches for foreign key. Okay. So I very seldom, if ever, I don't think I've ever used set null or set default. I use cascade where it's appropriate, and I use no action where it's appropriate. So that is your referential constraint. It has a huge amount of power, and this alone, I can guarantee, will get rid of 30% of the lines of RPG code that currently exist in your applications. Because this replaces every single set lower limit or chain to check for the existence of a record. It gets rid of complex routines to delete dependent records. It makes sure that you can't put in an orphan record. You can't put in an invoice line that doesn't have an invoice header. All of that type of stuff that we check, or we should be checking, and I say that with a smile on my face, that we should be checking within our application code can all be done away with. Because the database is doing it. And when you take it a step further, these relationships are handled by the database. Even the good old standby DFU cannot bypass these referential constraints. If I attempt to add a record into this foreign key file by DFU, and it doesn't have a parent file record, DFU will fail. Any SQL client that you choose cannot get past this because this relationship is built into the database.